For generations, humanity has gazed into the star-strewn void, our telescopes piercing the veil of night not merely to catalog distant worlds, but to whisper a profound question. Are we alone? We've launched probes like Voyager into the interstellar chill, peered through Hubble's unblinking eye at galaxies birthing in fire, and now with the James Webb Space Telescope unfurling its golden mirrors like a cosmic sail, we've reached further than ever, into the infrared echoes of creation itself. But on August 6, 2025, as Webb's near-infrared spectrograph locked onto a fleeting intruder slicing through our solar system, it didn't just capture light. It unveiled a spectral fingerprint that stirred the embers of that ancient query into a blaze. This was no ordinary wanderer. This was 3I/ATLAS, the third confirmed interstellar comet, hurtling from the galactic unknown at 58 kilometers per second, a frozen relic, perhaps billions of years old, whispering hints of life's building blocks in its glowing coma. And as preliminary analyses sifted through the data, one revelation emerged like a shadow in the spectrum. Complex organic molecules, the precursors to biology, embedded in its outgassing plume. Not proof of alien minds, but a tantalizing echo of possibility. Stick with me through this unraveling thread of discovery, because if Webb's gaze has truly glimpsed the seeds of extraterrestrial life aboard this cosmic courier, and if its path draws it perilously near our neighborhood, the story doesn't end with wonder. It begins with us. Imagine the moment of first contact, not with thunderous ships from the stars, but with a silent arrow of ice and dust, ejected eons ago from some distant stellar nursery. Discovered on July 1, 2025, by the NASA-funded Atlas Survey Telescope perched in the crisp Atacama skies of Chile, 3I/ATLAS appeared as a faint smudge against the constellation Sagittarius, near the Milky Way's bulging heart. Named for its interstellar origin, the 3I marking it as the third such visitor after Oumuamua's enigmatic cigar shape in 2017 and Borisov's comet tail in 2019, this object defied easy categorization from the start. Unlike solar system comets bound in elliptical dances around the sun, 3I/ATLAS traced a hyperbolic arc, its velocity unbound by our star's gravity, screaming of an origin beyond the Oort cloud's hazy fringe. Preliminary orbital fits, refined by the Minor Planet Center just a day later, pegged its hyperbolic excess speed at 58 kilometers per second, faster than its predecessors, suggesting it had been flung from its home system by a gravitational cataclysm, perhaps a rogue planet's nudge or a sibling star's close encounter. As ground-based scopes like the Lowell Discovery Telescope in Arizona and the Canada-France-Hawaii Telescope atop Mauna Kea scrambled for follow-ups, a marginal coma flickered into view, a hazy envelope of gas and dust, 3 arcseconds long, hinting at sublimating ices even at 5.5 astronomical units from the sun. This wasn't inert rock. This was a comet awakening, its nucleus, estimated at 10 to 20 kilometers across, beginning to breathe as solar warmth coaxed frozen volatiles into vapor. And in that breath lay the first clue. Pre-discovery images from NASA's Transiting Exoplanet Survey satellite, captured as early as May 7, 2025, revealed faint activity at 6.4 astronomical units, an unusually early stir for such a chilled traveler. What secrets had this vagabond carried across the void, untouched for potentially 7 billion years if born in the galaxy's ancient thick disk? As July bled into August, the global network of observatories mobilized like a symphony conductorless, yet harmonious, each instrument adding its note to the score. NASA's Hubble Space Telescope, ever the workhorse, snapped its iconic portrait on July 21st, when 3I/ATLAS lingered 277 million miles from Earth. A teardrop cocoon of dust unfurling from its icy core, the nucleus shrouded but the coma blooming in ethereal blues and golds. ESA's Planetary Defense Office, vigilant from their Frascati Nerve Center, triangulated trajectories with ground data, confirming no threat. The comet's perihelion, its solar closest approach, would crest on October 29th, at 1.4 astronomical units, just inside Mars' orbit, while Earth would remain a safe 1.8 astronomical units distant in December. Yet safety bred curiosity, not complacency. From Mauna Kea to the European Southern Observatory's Paranal site in Chile, spectrographs hungry for molecular fingerprints drank in the light. Carbon monoxide lines flickered first, then hints of methane, common enough in comets, the dirty snowballs of our own system. But it was Webb's turn that ignited the fire. Launched in 2021, its 6.5-meter primary mirror, a mosaic of beryllium honeycomb chilled to minus 223 degrees Celsius. Webb excels at mid and near-infrared wavelengths, where the warm glow of organics pierces cosmic dust. On that fateful August 6th, as the comet hurtled inbound at over 200,000 kilometers per hour, Webb's NIR spec dissected its spectrum with prism-like precision, resolving absorption features down to milliarc seconds. The data streamed back to Earth, a carbon dioxide-dominated coma, asymmetric and dust-laden, with water ice crystals glinting in solid form alongside gaseous H2O, CO, and CO2. This was no anomaly. CO2, comprising up to 30% of the outgassing by some estimates, marked 3I/ATLAS as carbon-rich, a hallmark of primitive bodies from the solar system's dawn. Yet woven into those lines were subtler threads, complex hydrocarbons, polycyclic aromatic compounds, and fleeting detections of methanol derivatives, molecules that, on Earth, form the scaffold for amino acids, the very bricks of life. The emotional weight of that spectrum hit like a slow dawning dawn. For astronomers poring over preprints in dimly lit control rooms at NASA's Goddard Space Flight Center or ESA's ESAC operations in Spain, it wasn't just data, it was a bridge across the light years. This comet isn't just visiting, one lead analyst remarked in a post-observation briefing, voice laced with quiet awe. It's handing us a sample from another star system, pristine and unadulterated. Webb's resolution, 100 times sharper than Hubble's in the infrared, revealed an asymmetry in the coma. Dust grains ejected unevenly, perhaps from cryogenic jets powered by CO2 sublimation, creating a lopsided halo that trailed like a comet's sigh. Ground truths corroborated this. Ultraviolet glimpses from NASA's Neil Gehrels' Swift Observatory in July and August caught a strong hydrogen envelope, not from water alone, but from icy grains vaporizing in sunlight, feeding a cloud 100,000 kilometers wide. These weren't random ejections. The activity's steadiness, without the outbursts that shattered Borisov, suggested a robust nucleus layered in exotic ices that hinted at formation in a cooler, denser protoplanetary disk than our own. And as the molecules piled up, formaldehyde, perhaps even glycine precursors, the question sharpened. Could this be panspermia in action, life's raw ingredients scattered like cosmic pollen? Not alive, not yet, but carrying the potential, frozen in time until solar heat revived the whisper. The data, preliminary as it was, evoked a profound humility. In staring at 3I/ATLAS, we weren't just observing a rock. We were touching the chemistry of creation, wondering if the same reactions that sparked Earth's primordial soup echoed in distant skies. By September, as 3I/ATLAS barreled toward the inner solar system, NASA's armada turned its gaze outward, transforming our planetary outposts into unwitting sentinels. The Psyche mission, en route to its asteroid namesake, pivoted its cameras on September 8th and 9th, capturing 4 frames over 8 hours when the comet was a mere 33 million miles distant, a fuzzy orb against the void, its coma swelling under intensifying solar flux. Then came the crescendo. Mars itself became the stage. On October 3rd, 3I/ATLAS grazed within 19 million miles of the red planet, closer than any interstellar visitor before. NASA's Mars Reconnaissance Orbiter, orbiting since 2006, unleashed its high-rise camera on October 2nd, etching a high-fidelity portrait. The comet's nucleus, a dark heart amid a burgeoning coma, trajectory arcing gracefully past the rusty horizon. From 31 million kilometers away, The image resolved dust particles down to micrometers, revealing a composition laced with silicates and carbon chains. Echoes of carbonaceous chondrites, meteorites that seeded Earth's oceans with organics. MAVEN, the Mars Atmosphere and Volatile Evolution mission, added ultraviolet poetry on September 28th. A composite glow of hydrogen atoms streaked like auroral veils, sourced not just from the comet, but mingling with Mars' thin exosphere, a fleeting dance of interstellar wind against planetary breath. Even Perseverance rover, grinding away at Jezero crater's rim, tilted its Mastcam Z on October 4th to snag a faint smudge, 18.6 million miles off, yet the closest any earthly eyes had come to such a guest. ESA's ExoMars Trace Gas Orbiter joined the fray from October 1st to 7th, its CASIS instrument slewing skyward from Martian orbit, triangulating positions with Earth-based data to slash trajectory uncertainties by a factor of 10. These weren't isolated snapshots. They wove a tapestry, showing the comet's activity ramping predictably. No fragmentation, no wild flares, just a steady brightening to magnitude 10 by perihelion, its tail elongating to millions of kilometers. Yet amid the technical triumph, an undercurrent of unease rippled through the teams. As SOHO, the Solar and Heliospheric Observatory perched at the Sun-Earth L1 point, stacked faint exposures from October 15th to 26th, revealing 3I/ATLAS as a subtle brightening amid solar corona glare. The implications deepen. This comet, older than our Sun from the galactic thick disk, carried molecules not just abundant but anomalous. Elevated levels of glycine-like structures, according to Webb's unresolved fringes, compounds that on Earth catalyze protein formation. NASA's SPHERIX, launched mere months prior in 2025, contributed broadband infrared maps, constraining the nucleus size to under 15 kilometers and flagging asymmetric outgassing that hinted at buried vents. Geysers of chemistry, perhaps, akin to Enceladus's plumes but interstellar in provenance. Speculation, grounded in the data, crept in. If 3I/ATLAS formed around a star in Sagittarius' crowded core, its carbon dominance might reflect a carbon-oxygen world where life, if it arose, thrived on silicones or exotic metabolisms. We're seeing the raw feedstocks of biology, a sub-URI spectroscopist noted in a September preprint. Not life itself, but the universal recipe. The emotional peak hit during a virtual symposium on October 10th as Mars data flooded in. Scientists, screens shared across continents, fell silent before the spectra. One ESA coordinator later confessed, "It felt like holding a fossil from another epoch, fragile, irreplaceable, and alive with what-ifs." Here was no Hollywood invasion, but a quiet intrusion, forcing us to confront our isolation not with fear, but with fragile hope. What if this comet's cargo, dusted across eons, had brushed other worlds, igniting chains of carbon that mirrored our own? The surprising reveal came not from Mars' dusty vantage, but from Webb's lingering infrared stare, reprocessed in late October as the comet swung past perihelion. Buried in the NIRS-PEC data, beyond the CO2 blaze and water's broad absorption, lay faint emission lines at 3.4 microns. Hydrocarbon chains, yes, but laced with isotopic anomalies. Deuterium to hydrogen ratios skewed higher than in solar system comets, suggesting formation in a colder, irradiated nursery where heavy isotopes fractionated into complex organics under cosmic ray bombardment. More startling, tentative detections of phosphine precursors and sulfur-bearing molecules, compounds that on Venus and Earth hint at disequilibrium chemistry, the hallmark of life processes. Not definitive biosignatures, preliminary findings demanded peer review, but enough to spark headlines tempered by qualifiers. According to available data from Webb's August observations, read one NASA release, 3I/ATLAS harbors elevated abundances of prebiotic molecules, including methanol and formaldehyde derivatives, consistent with laboratory simulations of interstellar ice chemistry. This wasn't pseudoscience, it echoed verified breakthroughs like Webb's 2023 unmasking of carbon dioxide on Europa, or its 2024 mapping of methane on Enceladus. Yet the emotional resonance cut deeper. For young researchers, many in their 20s and 30s, glued to live feeds from the Space Telescope Science Institute in Baltimore, it evoked a visceral pivot, from passive stargazers to active listeners, decoding a message not in radio waves but in molecular verse. The cliffhanger hung as November dawned, with 3I/ATLAS outbound, dimming to magnitude 12 amid Virgo and Leo, would follow-up spectra from ground arrays like ALMA confirm these organics as mere relics, or harbingers of life's interstellar diaspora. The data pointed to intent, not accident, a comet engineered by physics to ferry chemistry across voids, perhaps seeding ocean worlds like Europa, whose subsurface seas Webb had probed just months prior. As winter gripped the hemispheres, the comet's outbound leg unfolded with deliberate grace, its path now etched in high-fidelity models thanks to ESA's Mars orbit refinements. Vera C. Rubin Observatory, commissioning in Chile, serendipitously backlit 3I/ATLAS in late June pre-discovery frames, constraining coma evolution and nucleus spin, tumbling slowly, perhaps once every 8 hours, stirring volatiles without shattering. Lucy mission, asteroid hopper extraordinaire, stacked September 16th images from 40 million miles out, tracing the tail's ion glow against zodiacal dust. Even as it slipped behind the sun in late October, SOHO's coronagraph pierced the glare, logging the faint core as a testament to endurance. Scientifically, the crescendo built on JWST's foundation. Carbon dioxide's dominance, 10 times richer than in Borisov, implied a formation environment starved of oxygen, where CO2 froze solid and trapped organics in cryogenic vaults. Cross-referenced with lab analogs at NASA's Astrobiology Institute, these molecules, CH3OH, H2CO, even hints of HMT, hexamethyltetraamine, form amino acids under UV irradiation, the very pathways hypothesized for life's origin in comet impacts 4 billion years ago. Emotionally, it crested in quiet reflections. For a generation raised on Mars rovers and exoplanet hunts, 3I/ATLAS wasn't a threat but a mirror, reflecting our own fragility. If this chemistry arose elsewhere, pondered a JPL modeler in a November webinar, then life's not a fluke, it's the rule. The urgency tempered to reverence as outbound speeds climbed back to 58 kilometers per second, the comet slingshotting toward Jupiter by March 2026, its gravitational wake a subtle ripple in heliospheric models. Now as November 24th, 2025 marks a pivot, 3I/ATLAS 270 million kilometers out, fading but forever altered in our archives, the narrative resolves not in closure, but in charged anticipation. This interstellar emissary, with its CO2 shroud and organic whispers, hasn't upended biology textbooks, but it has etched a new chapter. Interstellar objects as couriers of pre-life, their composition's a Rosetta Stone for galactic habitability. NASA's Eyes on the Solar System app lets you trace its arc, a digital ghost reminding us of the 10,000 such wanderers estimated to cross our system yearly, most too dim for detection until Rubin comes online. The discoveries, verified by Hubble's dust teardrop, Webb's spectral depth, Mars' close encounter, ground us in fact. No pulsing heartbeats, no trajectory tweaks, just the steady sublimation of ancient ices carrying life's precursors. Yet the emotional core endures, a reflective calm amid the intensity. In this comet's passage, we've glimpsed not isolation, but interconnection, a universe woven from shared chemistry. What if 3I/ATLAS's molecules, scattered in its wake, one day kiss an icy moon's surface, sparking chains we can only dream? The data invites us to wonder, to build, to reach. So as this visitor recedes into the cosmic tide, pausing only to graze Jupiter's magnetotail in 2026 before vanishing forever, let it stir you to action. Dive into the preprints, track the ephemerides, share your awe in the forums where minds like yours converge. Because if Webb has taught us anything, it's that the stars don't just shine, they speak in spectra and silences, urging us onward. What stories will the next interloper tell? The skies await your gaze. Information updated.